you should always let us know. And that's pretty much it. So today's talk is very, very exciting. So 2 weeks ago, we did the science of history, and this week we're doing the history of science, which is like a really good switch. And Shireen and Claire are two PhD students from different institutions. They'll introduce themselves as well, but their talk's title is Whose Science, Whose History? Why the History of Science Matters. So I'll let you both take it away.
Thank you so much, Busa, and to everyone on the Sit-in team, Science in the News team. It's been a real pleasure for Claire and I to collaborate with all of you. So I'll just briefly start by introducing myself. I'm Shireen Hamza. I'm a PhD student in Harvard's History of Science department, and I work on the history of science and especially medicine in Islam in the medieval Indian Ocean world. So the main areas that I focus on are Yemen and South Asia, specifically like the western regions of India. I'm interested in healing traditions in these places and times. And I am calling in today from Chicago, which is historically the homeland of the Council of the Three Fires, the Ojibwe, Odawa, and Potawatomi nations. And this is the unceded traditional homelands of these nations. And I'd like to acknowledge that I offer my respect to the elders of these nations and commit myself to the rightful return of their land.
Hello, I am Claire Sabel. I'm a PhD student in the History and Sociology of Science department at the University of Pennsylvania, where I study the history of the earth sciences, primarily in the 17th century, and I look at the role of the Indian Ocean gem trade and its influence on questions about the composition of the earth. I am calling in from Philadelphia, close by the University of Pennsylvania campus, which stands on the indigenous territory known as Lenape-Hoking, the traditional homelands of Lenape peoples, also called the Lenni Lenape or the Delaware Indians. These are the people who in the 1680s negotiated with William Penn to facilitate the founding of the colony of Pennsylvania, and their descendants today include the Delaware tribe and Delaware Nation of Oklahoma, the Nanticoke Lenni Lenape, the Ramapo Lenape, the Powhatan Lenape of New Jersey, and the Munsee Delaware of Ontario. So as you've just heard, we are covering many different geographies already in this talk, as well as timescales. And we want to acknowledge that while we want to think globally and across a lot of different times and spaces, that we're primarily talking from our personal experiences in US education systems. Although we'll be talking about how those systems are part of longer and global histories.
So to begin, we'd like to ask for some audience participation. Without giving it too much thought, please, for those of you on Zoom, add to the chat the name of a famous scientist. Oh, sorry, a famous scientist from history.
Okay, I've seen Marie Curie, Albert Einstein, both popular choices. Glad to see at least one woman represented so far. Newton, Carl Sagan, Hypatia, ancient mathematician. Tesla, I guess we're thinking Nicholas Tesla, although maybe the whole Tesla enterprise, which would be a cool take on this question. But yeah, Tesla was the focus of a recent biopic, so I think he's also fresh in people's minds, as was Marie Curie, actually. Galileo Galilei, who will appear later in our talk, so I'm glad that he made an appearance here. But these are great. These are a few, of the most common names that we hear all the time, especially people like Newton, Copernicus, and Galileo. Some famous, James Clerk Maxwell. I did check Wikipedia's History of Science page for who the most famous historians of science are. Maxwell makes the cut, historical figures. And yeah, I mean, so these are, we've got a few, with Hypatia and Marie Curie, we have a few women, but not surprisingly, these are mostly men. We've got quite a few people from the 17th century, quite a few people from the 20th century, and a number of physicists, which fits a lot of our trends, the trends that people commonly associate with science, and they're the ones that we chose to represent and reflect on in the graphic for this talk, which was really beautifully done by another Harvard graduate student, Colonialism.
And the answers that we've just seen in the chat reflect really popular and well-known perceptions about what science is, who does science, where it happens, but it doesn't quite match up with the way historians of science think about how science has worked historically, or how it works today. So we really think our field has a lot to offer everyone interested in science. Historians of science, technology, and medicine often study questions about how, we study how questions about the natural world get formed. How do they get asked? And how do they get answered? Who poses them? Who answers them? What methods do they use? So, for example, why across time has it been so important in so many societies to correctly predict the movement of stars? Or what makes the building of an observatory for astrophysics and astronomy the most important use of sacred land, like Mauna Kea on Hawaii? Or why do geneticists continue to refer back to race in their research? And what overall has science meant to people in the past? We're a little less interested in how correct the science of the people in the past seems to us now. After all, if we think about what our science is going to seem like to people 100 years in the future, it's maybe not going to seem so right to them anymore. So our discipline tries to focus on questions of what science in the past has meant to people, why they did it, and what it has meant to all of the people who made it, and what their roles were in these endeavors. Asking questions about how scientific expertise and disciplines, like, for example, biology, physics, mathematics, etc., change over time is another one of our fortes in the history of science. We choose to honor and reflect certain stories about the history of science today, whether we're in science classrooms or writing a Wikipedia article or, giving a lecture online. And these histories that we choose to reflect really show what our values are about science today. What do we value? What do we think is important? So in this talk, we're going to reflect a little more on how the past study of science and the way we understand its history inflects the presence of science today.
Great, so here's a good moment to pause and define what we mean by science, which we want to expand far beyond just the individuals who you raised before, and think about sort of why is it that those individuals have become seen to be representative of science. So for us, and in our field, when we think about science, there are two kind of important dimensions of what science is. The first is the contents of a form of knowledge. So science could be said to be basically any way that people think about the natural world. And the second way is science is a particularly authoritative body of knowledge within any given society. And we want to recognize as historians that historically there have been many ways of thinking about the body, means of studying the stars, identifying edible foods, and that there's a history to how those different forms of knowledge did or did not come to be recognized and taught to us as important forms of science or important historical figures, which I think was really nicely illustrated by the range of individuals who our audience selected so far. History of science helps us understand how these two forms of knowledge, both its the natural nature of knowledge and its social authority, come to be connected, as well as the consequences of legitimizing certain forms of knowledge over others. The power of science today is that it's a form of expertise that has almost a unique power to be recognized and seen as applicable to a huge range of social problems and to a huge range of societies. And in this talk, we want to show how the history of how this has come to happen shows two important things beyond just this beyond its or about the way that science's power works. The first is that science doesn't affect everyone equally, and it often reflects social inequalities, both in the way that it's been practiced and in its effects. And secondly, that it's often been selectively defined to emphasize certain interests and celebrated as universal in spite of its uneven impacts and benefits. Scholar of race and technology, Ruha Benjamin, has a really, I think, poignant way of encapsulating this, the way that science's different knowledge stories can also imprison us as well as they can illuminate the world. And she says, this is a quote from a talk that she gave in 2019, is the first of many further readings and other kinds of media that you can learn more about some of the themes from our talk today that's featured in our handout. So according to Dr. Benjamin, we should acknowledge that most people are forced to live inside someone else's imagination. The nightmares that many people are forced to endure are the underside of an elite fantasy about efficiency, profit, and social control. Racism, among other axes of domination, helps to produce this fragmented imagination, misery for some and monopoly for others.
As Claire has said, the way that science affects us really does vary, and that is one of the things that has varied across time. So though we're not suggesting that science has always been in the same relationship to society throughout the past and the present, we do want to show how science in the past, the present, and hopefully in the future are deeply connected. And the beautiful graphic made for us by Karina Loeb can maybe help us get into these ideas more. So in this graphic, an island sits on a lake under a rising moon. On top of the island is a stone circle, surrounded by people observing the sky. While the moon is traced with many concentric circles, the intricate metal work on an astrolabe both the stone circle and the astrolabe have long been used across Africa, Europe, and Asia to understand and measure the movement of astral bodies. Meanwhile, reflected in the lake, we see instruments more familiar to us. Someone's at a computer, someone's looking through a telescope, and instead of a stone circle, we see the satellites of a huge array telescope. Modern science often presents itself as very different from the Dark Ages, the science in the past, a time when people really didn't understand the natural world. But as we'll show today, they are deeply connected, and many aspects of the sciences we use today actually stretch back into antiquity. Finally, we see that there's a person paddling a canoe, breaking the barrier of water and reflection, past and present. This figure acknowledges that certain historical practices are continuous into the present, like Polynesian navigation, despite the processes of colonialism, which have nearly wiped this process of navigation out. And we'll talk more about colonialism later. The Polynesian Voyaging Society is continuously making worldwide journeys on the hokulea, a double-hulled canoe. They use traditional navigational methods in their journeys. They don't use a GPS or other tools. And they've been doing this since their very first voyage in 1976. And something we can take away from this graphic is that both the past and the present, science is deeply collaborative and requires the coordination of many, many people.
So why should we care about these forms of science in the past? In this remainder of this part of the talk, we'll show a little bit more about how they influence science education, public understanding of science, and the training of scientists. And there's a really illustrative example of this in a 2006 study produced by scholars, educational researchers at Columbia and the University of Washington, called Even Einstein Struggled. And in this paper, they show how sharing Einstein's story within a science classroom to two different groups of students produced two very different outcomes. So for the first group of students, who were covering a physics lesson through the story of Einstein. They learned that Einstein was a unique genius who made world-changing contributions to our understanding of physics. For the second group of students, they learned that Einstein was an individual who really struggled to make his ideas known, who struggled in his personal life, and who eventually succeeded. And what these researchers found was that the students in the second group who learned about the kind of human side of Einstein's story tended to be much more motivated in their approach to their curriculum and indeed to get markedly better outcomes. And it may not be that surprising that humanizing science helps people relate to it better, but it's an elegant demonstration of something that we sort of might intuitively feel to be true, and something that is very starkly reflected in the statistics that are collected by the National Science Foundation's report published every 2 years on the representation of women, minorities, and persons with disabilities in STEM fields. These statistics, which are collected in very detailed ways about not only who gets a doctorate in science and engineering, but also who goes into the various professions, show consistently that women, people with disabilities, and minorities do not reflect, despite their significant proportions of the US population are not accurately represented in those fields. And so we'll, even just in this way, we can think about how the stories that scientists learn, the stories that students learn about who a scientist is and what a scientist looks like, which is also a feature that you should check out of Science in the News, influence who becomes a scientist, right? So that the stories we tell within our society about who can access science and what a scientist looks like directly influence who ends up pursuing those degrees and working in those fields.
And ironically, though it's obviously very useful and helpful that the National Science Foundation is collecting these statistics, the very categories that they're using, like white, Hispanic, Asian, Black, these are categories that were created by scientists by scientists in relation to other people in society. And it's the legacy of a particular kind of science, race science. These categories may be socially constructed, meaning they were made by people and institutions, but activists who, for example, have contested them have also participated in their creation and their deployment. It's a very dynamic process. And the meaning of each of these categories has shifted greatly over time. I think the meaning of white having shifted greatly over the course of the 20th century in the US is a very common story that people use to bring this up and to talk about this. But the main point here for our purposes is that technologies create and reproduce categories, but these constructed categories are then appropriated by a range of people in society and even sometimes come to play a role in the way people see themselves. So they are both constructed and real in some way at the same time. And historians of science have really tried to show the social construction of a number of things. For example, who is the ideal scientist in a given time and place? This is another concept that's really shifted historically. The ideals of an 18th or 17th century gentleman science in the Royal Society is certainly not what would be required of someone trying to get their PhD today. Not entirely. But phrases like the invisible technician captured this sort of flip side of this. This was a phrase used often by historian Steve Shapin and by many others in the field to capture the way that many people in the shadows people who don't necessarily fit the role of the ideal scientist participated in or even did a lot of the science in a real way, even though their names aren't necessarily on the papers, on the published papers, or on the letters exchanged between scientists historically. So the ideal scientist is a sort of concept and a way of understanding who a scientist is that gives a very misleading impression of how scientific and technical achievements happen. And sometimes it can mistakenly justify forms of unequal recognition, such as financial compensation today, and historically. So we believe that science should support the fair compensation of all of its participants and should reflect on how to further value the labor of all participants, not just those at the very top of this hierarchy.
And so finding historical examples of invisible technicians doesn't only serve as sort of a motivational story, it actually, as Shireen said, gives us a better idea of how science works. Take the recent example of Margot Lee Shetterly's book, Hidden Figures, which was adapted into a feature film, which I highly recommend, which recounts the central role of Black female calculators or human computers who did the crucial calculations for the first American orbital space flight, working at one of NASA's research centers in Virginia in the 1960s. In spite of Black women having unequal social opportunities and educational access, they still made vital contributions to the American space program. And Margot Lee Shetterly herself actually grew up in this community and told its story really beautifully. And so this question of the story of the American space program allows us to make an even more important point, which is that we get to tell multiple stories. We can choose to tell stories in ways that represent the diversity of figures of their contributions. This is really wonderfully encapsulated by novelist Chimamanda Adiche, which is the quote that we used to kind of direct sort of our overall inspiration for this talk, who says that the single story creates stereotypes, and the problem with these stereotypes is not that they are untrue, but that they are incomplete, and they make one story become the only story. Stories matter, and many stories matter. Stories have been used to dispossess and to malign, but stories can be used to empower and to humanize. Stories can break the dignity of a people, but stories can also repair that broken dignity. When we reject the single story, when we realize that there is never a single story about any place, we regain a kind of paradise. And so it feels maybe a little bit too soon to go shift from paradise to the contemporary COVID pandemic, but the history of vaccination actually is a really illustrative example of the sort of dangers of the single story versus the power of the multiple stories. So often vaccination is talked about in terms of the singular invention of Edward Jenner, a British physician who introduced the concept of vaccination by using some of a disease related to smallpox found in cows and cowpox, which is actually where the name vaccination comes from. It's derived from the Latin word for cow. So Jenner realized that a closely related disease that was less virulent, some of the pus from the cowpox could be injected into a healthy subject, and that would actually improve their immunity to the smallpox, the ravages of smallpox. But focusing on this single invention obscures the fact that there were many, many other things that had to happen for Jenner to be able to have this insight. Most of all, the fact of the fact that injecting pus from a smallpox pustule into a healthy patient was actually already fairly well known in England because it was introduced through Lady Mary Wortley Montagu, who was married to a 17th century ambassador to Istanbul, where she learned of the practice in the Ottoman Empire. And that was sort of the tip of the iceberg of a much wider spread knowledge of what was called variolation, just in using the material from the disease and injecting it into healthy subjects that was widespread across Asia, Africa, and the Middle East. And in fact, was introduced into the United States in the colony of Massachusetts by enslaved West Africans. So do we choose to tell the story of the history of vaccination as a single discovery by one person, or of centuries of experimentation by many different communities across the globe? And we could tell the same story about the history of our own COVID-19 vaccination today, in which the majority of the resources have been put into the discovery of the vaccine, and very little has been done to, comparatively to recognize the role of many different communities in distributing and implementing those vaccines. And we're really seeing the disproportionate suffering across different health systems worldwide as a result of that. So in the next part of the talk, we'll think not just about who are all the people that have participated in the processes of science, technologies, and medicine, and as well as how historians play a role in finding more just histories of this question. But we'll also think about what narratives of scientific discovery have meant to scientists.
And in this first part of the talk, just to recap briefly, we've covered who is telling the story and who is sanctioning that story as the real history of science, for example, really affects the story that's being told. Storytelling has consequences for what people learn is science and how people learn science, how well people learn science as well. But historical research, including the kind of work that's being done in our field right now in the history of science, can really bring many new voices and stories and contributions from the past into our present understandings of science. Finally, understanding that science has been made by a variety of different communities over time can perhaps help make its current implementation more just by and for all of the communities that science impacts today. And with that, we will turn to questions.
Thanks so much, Shireen and Claire, for really great talk so far. And we already have a couple questions coming in, but I do want to encourage everyone listening, both in Zoom and on YouTube. If you have questions, you can drop them in the chat now, and we will relay them to the speakers. One of the first questions we have is, what does it mean for something to be socially constructed?
I guess one example might be, just to go back to the example we gave on the slide of who is considered white in the United States. So in the early 20th century, there were many people who are maybe perhaps now no one would question whether they're white, whether that might be Italian Americans, Irish Americans, even some folks who are Ashkenazi Jewish. They can sort of pass, or many people wouldn't question whether they're white or not. This isn't true of everyone. These are generalized statements. But that's how it is now. Like, they can kind of be assimilated into this category of white. But in the early 20th century, they absolutely were excluded from this category. Some people were denied legal right to be in this country, and as well as many labor rights, many other rights. And so we would say this category is socially constructed. But, part of that construction was scientists playing a role in the way that, say, like the Aryan race was considered to be, rooted in biology. So even though biological explanations were supplied, that biology in and of itself was shaped by society's understandings of science and society, and thus all came together into this category of white. So that's just one example. Hope that makes it a little more clear.
Yeah, thank you. And if there are follow-up questions, definitely you can drop those in the chat as well. One other question we have is, how can we recover stories of invisible technicians who were written out of history/science so far? What resources or strategies exist?
I would say that's a huge part of what our PhD training is about. It really begins with setting the intention to look for those people, and also recognizing that they're not necessarily written about, or they weren't necessarily writing about their own experiences. The records that remain usually reflect the kind of dominant group and their interest in preserving their own histories. So a lot of it is reading really carefully, looking for people who were only fleetingly mentioned, and realizing that if they're fleetingly mentioned, they were definitely there, and someone thought they weren't that. Someone who was important enough to write something down may have thought that they weren't that important, and that's kind of, reverse engineering of the process that historians do. It also means looking beyond things that are canonically recognized as science. So in my research, I use a lot of commercial sources. So these were documents written by merchants who talk about the forms of expertise that they encountered in the marketplace, which is a way of understanding things that might not have been written down, but were certainly widely spread in practice and observed as forms of expertise.
Fantastic. Thank you. I think we have at least one more question. And this one is, how can individual scientists reflect on their work and identify the ways in which it impacts people unequally?
That is such a great question. I really hope you'll be able to stick around for parts 2 and 3, especially part 3 of the talk, as we're definitely going to get into that more. But maybe very briefly, I think history can play a really big role in that. So before maybe working with a given community or, thinking about the way that something will be like assumed to be implemented in a given community, finding out historically what that community's relationship with science and scientists has been can often make a huge difference, and kind of thinking about shifting the relationship between scientists as this kind of objective external person with all the knowledge, and the community as kind of the people to be studied or the people to be helped or delivered objects and information to, shifting that relationship to something that's a little more equal and has more respect, I think is a great step that many scientists are already taking and have taken to great effect. So in the first part of this talk, we covered the ways that science influences, the way that the stories we tell about science influences how people understand what science is, who a scientist is, who an ideal scientist is, and maybe who are the people in the shadows as a result of that. And in the second part of the talk, we'll take a closer look at where prevailing ideas about science's past have come from, and how these histories were used by people at different points in time. So we noted in part 1 that the questions scientists ask and the answers that they come up with reflect their worldviews. And we can extend the same analysis to the history of our own field, the history of science, to see how at different points in time, historians of science have responded to their circumstances to try and make use of science's past. The history of science was not founded as its own department in universities in the US until after World War II. Founding departments was an important step that one could take in order to establish something as a field of research and to create kind of a community of researchers. So one such founder, George Sarton, who was Belgian, he thought the history of science could be used to further dialogue about science in broader society after World War II. So in the wake of penicillin and the atomic bomb, people were increasingly aware of the influence that science had in their lives. Sarton hoped that the discipline of the history of science could further international cooperation for peace, which mirrored his research into the connectivity of medieval science, ancient and medieval science, in Europe, Asia, and Africa. In and out of departments, this discipline was also supported by nation states. So one of Sarton's first students, Aydin Saili, pictured here, returned to Turkey to work for the Kemalist government after he graduated from Harvard. He is maybe the most famous historian of science ever, as his face was actually issued on a 5 lira banknote. Turkey, like many countries in the 20th century, was grappling with the legacies of European colonialism. New countries like Turkey wanted to prove that they were modern in the 20th century, a time when European dominance was taken for granted. Everyone else outside of Europe had something to prove. So what is colonialism? Empires have existed throughout history, but from the 16th century onward, a small number of empires intensified their occupation and annexation of land, as well as the extraction of natural resources, including enslaved people, from their colonies. This more recent process of the last 5 centuries is what Claire and I mean by colonialism for the purposes of this talk. So just like Sarton and his contemporaries had their own goals for the history of science, colonial powers also wanted to craft a narrative to support their interests. Science had been deployed in the service of colonial interests by, for example, equating modern science with Western science. And by doing so, empires had justified the superior civilization of colonizers over colonized. Colonial narratives of the history of science, for example, were imposed by the British in India through education reform. So that's how they made it into classrooms. However, after anti-colonial struggles, post-colonial nations became independent. And these countries also funded the production of counter-narratives. For example, Turkey's decision to fund Aydin Sayeli, who was mentioned before. These newly independent countries had been told that science comes from Europe, and that their own traditions of knowledge and ways of knowing the natural world were inferior. So people wanted to prove otherwise. When funded by governments, these histories can support nationalist narratives, which present countries as the inheritors of scientific traditions. And this was perhaps meant to encourage young people to become scientists or to justify national spending on science and technology. Unfortunately, many of these national narratives centered the dominant group in these new nations, which sometimes resulted in the disastrous persecution and genocide of minorities, like the Armenian genocide in Turkey, or the persecution of Muslims, Christians, and Dalits under Hindu nationalism today. These national narratives were often informed by colonial history. The idea of India's golden age of Sanskrit science and its subsequent decline under Muslim rule emerged in British colonial accounts of the Indian past. The British wanted to show that the era of Indian science was over, so that Britain's superior civilization could prevail. But after India's independence, nationalists wanted to show how they could recover this golden age through investments in modern science. They affirmed the colonial story of a golden age, but they just changed its ending. These narratives just don't hold up, though. For example, historians have shown that Sanskrit learning was patronized throughout the medieval period by Mughals and other Muslim dynasties, as well as by British colonial officers in the modern period. In fact, along with other Indian knowledge systems, it deeply informed what we now call modern science. This history differs greatly in various settings, including places where settler colonialism is ongoing, for example, North America. And you can see our handout for more resources about that. But something that's really important to take away from this is that all narratives of the history of science, whether they're about Europe, whether about the rest of the world, whether they're by colonizers, new nations, or people who are anti-colonial activists, whoever they are, these people are making a decision about what should be called science before the 19th century and who should be called a scientist. Because these words, especially the word scientist, was only invented in the 19th century, and science only came to take on the meaning that it has today in that period. So when we choose to say, okay, this system of knowing the body, this system of looking at the stars or measuring their movement, that's science, we're making a decision. That's not the way that the people in that time and place viewed their knowledge. That's not the word they used for it, at least. So what informs these choices? The politics of our context.
So in walking through the ways that these narratives are constructed, we're trying to demonstrate that the idea that science is a universally true body of knowledge across time and space itself has a history, and that European dominance, the legacy of colonial educational institutions, naturalized a pervasive idea that science was born in Europe and Western in nature, and also a universally true system of knowledge. This emphasis has even affected the materials that historians have to write these histories. This is something that relates to the question asked earlier, in that through imperial violence, destructions of states, of palaces, of libraries, archives, and even the social fabric of different parts of the world through colonialism, not only criminalized and erased knowledge traditions, but even the material kind of written evidence of their existence. So in contrast, within Europe, which was relatively undisturbed by colonial upheavals, the scientific and other knowledge traditions could be cumulative, and they were much better preserved from the deep past. The artifacts, books, and letters that remained in European collections, as well as a lot of the materials needed to write histories of other parts of the world, were appropriated through these colonial histories, has further contributed to the prevailing idea of Europe as the center of what's often known as a scientific revolution, a singular moment, albeit over several centuries, that originated and disseminated from Europe. The central figures of this scientific revolution include some of the people mentioned earlier, like Isaac Newton and Galileo Galilei, whose very dependence often on imperial networks for some of the data and objects that they used has tended to be obscured because of this narrative of singular genius and scientific revolutionary, even while recent work by historians of science has shown how dependent they were on imperial networks for information. We can see the ways in which the scientific revolution itself was in many ways a 20th century phenomenon using this Google Ngram graph. And Ngrams are a really interesting way at looking at how concepts change over time, even though they draw on Google Books corpus of texts, every text that they have digitized. And you can look for a particular word and see in any given language when its usage across this corpus of books increased or decreased over time. And so the term scientific revolution, we can see really started to pick up after the institutionalization of the history of science. It was very central to the idea of science that it had a revolutionary moment and has sort of been on the up and up ever since then, just like the term scientific revolution since the 1950s. Saw a massive uptake in study and explanation. So this is really a testament to the work of George Sarton and his colleagues and the widespread investment in history of science as a form of science education, which was then propagated by philosophers, historians, and many others interested in sort of this phenomenon of science. Some of you may have heard one of the most popular terms to emerge from this post sort of 1950s study of science's history, which is the idea of a paradigm or paradigm shift, coined by Thomas Kuhn. Thomas Kuhn, after receiving a PhD in physics, began teaching history of science at Harvard through a program that was intended to use history of science as a means to explain science to the general public. So he used great historical examples, often centering canonical figures, often physicists, in order for non-scientists to learn how science works. But Kuhn's major contribution to our field was what he called the structure of scientific revolutions, which was an attempt to explain how past science changed over time and how scientists could come to a consensus at one point and then discard it and come to a totally new consensus while using often very similar methods and principles. And his greatest example was of the shift from a geocentric world to a heliocentric world, in which European mathematicians discarded their belief in the idea that the sun moved around the earth, instead positioning the sun at the center of the universe. And so one of the things that's really striking about Kuhn's paradigm and in his understanding of how science changes is that there is some kind of consistent mechanism through which scientific knowledge is achieved over time. Even when scientific consensus rapidly shifts, scientists and scientific knowledge are still operating within the same standards of proof and evidence. Kuhn was fundamentally invested in the idea that science could be studied without culture or location as a sort of universally sound way of producing knowledge, and that we just had to understand some of these internal mechanisms in order to get at how it worked. But in fact, his paradigms were narrowly confined within the model of a European scientific revolution, the revolution that he sort of took as his model, and couldn't really account for the much longer timescales and many different cultural contexts that have had to interact over time in order to produce much of science today. The numerals, some of them you can see on this slide, that we use are one such example, which have a history that stretches from ancient India and to the Middle East and Europe through the Middle Ages, when the Italian mathematician Fibonacci of Fibonacci numbers discussed what he called an Indian method of recording numerals, which was their introduction into Christian and Latin Europe, but which didn't actually catch on for another few centuries. And even took even longer for Arabic, so-called Arabic numerals to become a global standard today, even though they're just one of many numerals that are still, number systems that are still in use. So this is one of many examples of how what kinds of scientific knowledge catch on often have more to do with complicated social relationships and society's interactions than with the individual brilliance or success of an individual idea or group of researchers. But this issue of whether science is something that has essentially remained as consistent as a sort of protocol over time, or something that is culturally produced and very time and place specific, has been a sort of central tension within the field. And the success of Kuhn's program and his ideas of paradigms and revolutions created a number of competing interpretations and theories about the development of scientific knowledge, even while, as Shireen told us, a growing number of post-colonial scholars began to criticize these narratives, as extensively focused on Europe and North America. And this led to a sort of stalemate at the end of the 20th century in the 1990s in what is sometimes called the science wars, in which led to really vitriolic public debates, both in sort of popular media and in scholarship, about who the gatekeepers are for truth and belief, and who should have the authority to articulate what science can and cannot do. And therefore, who should be able to articulate and have expertise in the solutions to social problems. The science wars asked questions about who the gatekeepers are for truth and belief, who should have authority to articulate the solutions to social problems, and whether those solutions should be articulated by scientists, by people who study science, like Shireen and I, by politicians, other forms of experts, or even the community members of the communities most impacted by various problems. And the cumulative effect of these science wars was a lasting impact, especially in a rift between scientists and historians and philosophers of science, who were sort of seen as overly critical and untrustworthy, and therefore not supportive of the scientific enterprise. But this is starting to change, and collaboration is becoming more of the model. Scientists themselves, as we also heard in our kind of first question break, are becoming more interested in the history of their fields and disciplines, and are looking to partner often with other communities, form interdisciplinary partnerships within and as well as beyond universities. And so we'd like to sort of propose at the end of this section of the talk that if we can tell, or at least ask, if we tell fuller, more just and accurate histories of science, what does the future, our future, and the future of science look like? So we'll come back to that question about what's happening now and what we hope will continue to happen within science in the future. But to recap this part 2 before you take your second break, in this part of the talk, we've learned that history of science has come to mean the critical study of science and society, as well as the fact that European colonial interests created a prevailing dominant narrative of science as modern and Western that has been challenged by people over the world, but is often still commonly found in many communities today, even while historians have endeavored to show and challenge the story in a lot of ways by showing the longer timescales, many contributions, and often conflicts that have produced what we know as modern science. And lastly, that the legacy of the science wars from the 1990s still endures, and that in fact, historians of science talking directly to scientists isn't always as common as you may think. Any questions at this point?
If you have questions, please write them in the chat. We already have a few that came in, so we can get started, but please put them in the chat, either on YouTube or Zoom, if you have any. I'll start with one. Did many historians write about science before the history of science came up as a discipline? If so, was it different than the tone and scope of George Sarton?
That's a great question. Maybe both of us would have slightly different things to say about this. I think you could imagine kind of the way that pre-modern people before the modern people, understood their own scientific traditions and wrote internal histories of those. So, for example, what I study, the history of medicine and Islam, so the medieval Islamic world, for example, many people produced biographical dictionaries, and those people were often physicians themselves, trying to say, okay, well, where did medicine come from? Who are the different generations of physicians who came before, and how did this knowledge come to me? And also to try to kind of build a sense of the field, like, oh, these are the luminaries of my age. And one person I'm thinking of in particular who wrote a biographical dictionary in the 13th century, he's kind of notorious for having left out another really famous contemporary of his from his biographical dictionary, someone who, a lot of us study and are interested in. So I think that a lot of see some of the scientists here laughing, because I think it may be familiar that indeed before History of Science was founded as departments in US universities, scientists were really the ones producing a lot of work on the history of their disciplines. And they were interested in a number of things, but one of their interests was to kind of to craft the shape of the history of their discipline as it has come into the practice that they have today.
Cool. Do you have anything to add, Claire? Or
I think it's a great example. I mean, I think just to reiterate, the point that people, as sort of Shireen gave a really good example of the point we tried to make in part 2, which is that, the ways that history gets written reflects the priorities of the time. Often in 19th century Europe, for example, people were talking a lot about philosophy, sort of the history of philosophy, and focusing on that as a kind of authoritative form of knowledge. Or craft traditions also are a really interesting example of people writing down the history of, or even the recipes that they use, or the kinds of technical processes in which to make things. So they definitely reflect those, the way the history gets written reflects the sort of interests of who's recording it.
That actually leads to the next question we have so well. What are the differences between history and history of science as academic disciplines? Are there different methodologies? How about art history? Is it an older field than the history of science? And why do you think that's the case?
Claire, this one's a little complicated.
So I will say, in general, for people who've never heard of the history of science, I tend to use art history as a useful analogy, because it's we're asking historical questions, but we think the sort of object of our study it sort of deserves its own special interest group and its own techniques, right, for investigation, in the way that art historians are interested in sort of analyzing style, or they might look at the sort of technical, do a technical analysis of the components of paint. And there's also some kind of aesthetic appreciation that goes into art history. And I think all of those things we could say are analogous in the history of science. So there are people who are very invest a lot of time and effort into understanding the technical details of the sciences that they study, whether that's 13th century medicine or physics in the 1950s, and can explain to you in the way that a practitioner in that discipline would exactly how they would understand the contents of what they do. There are also people who are interested in the aesthetic dimensions of science, or how it presents itself. People who look at things like scientific images, or how scientists dress, or even things like how the term science has evolved over time, things like that. And we just think it's a powerful phenomenon and aspect of the human experience that does seem, in the way that sort of art history recognizes art has existed as a special kind of human activity in many times and places, that science seemed to be something really similar. So I think that's a really good analogy. As for why it hasn't existed for as long, the field of history of science, I think that really has to do with the cultural authority of science in the 20th century, in that art was just seen as a much more kind of higher form of calling, and than science was, often because of its association with kind of technology and practicality. People getting their hands dirty in other people's organs, or designing, weapons and ballistics and that kind of thing, is less of an elite practice than being involved in the arts or philosophy, things like that.
Yeah, something just really quickly that I like to give an example of is that I feel like a rock star in the medieval Islamic world was a poet. Like poets were way cooler and probably made way more money than like the alchemist, like trying to design a new gunpowder formula.
Thank you for that. I wanted to cut in with another sort of question that follows on. You both just mentioned development of weaponry and gunpowder. And one of the questions we have is, lots of science is still funded by departments of defense in different nations, including the US. Does the history of science tell us anything about how these funding agencies should operate?
Well, I think part 3 really does get into the kind of imperatives of science right now. I think funding is a really important question, and there was something I read in my first year by a historian of science that was titled "Follow the Money," that really showed that a lot of historians of science tend to study science that's either privately funded or in particular government institutions, big government institution, universities. But the actual ratio of funding is much larger for privately funded science than it is for publicly funded science. They were talking about specific disciplines, and I'm sure that defense is definitely one of the biggest spenders on anything. And so I think that there are, as was outlined in that article, there are many challenges to getting access to private companies' archives. Many of them have archivists, but depending on the kind of project you're doing, will you be granted access? What are you going to be allowed to see? What are you going to be allowed to publish? But yeah, we will come back to this in the third section. It's definitely an important topic.
I'll just add very quickly that, because I think the last part of the question was, how should that history inform, defense spending? And in some ways, I think it's sort of the opposite. It's sort of how should, history tells us that nations spend on science in defense of national interest or imperial interest. And knowing that history, how do we, whether you're a funded scientist or a member of the public whose taxpayers' dollars are being used, how do you then want to have a say in what gets funded and what doesn't? Because, the defense budgets will tend to be spent on issues that serve the interests of the Defense Department, right? And we all have a say in what those interests can or should be.
So in this third and final part of the talk, we're going to share some new directions within the history of science that may point us to a more just future for historians, scientists, and everyone else. You may have noticed that everything seems to be a lab these days. There's dance labs, media labs, and while these names may signal the experimental nature of the practice of people participating in them, they're also capitalizing on the cachet of science that I think Claire so beautifully articulated in the last Q&A. Similarly, many people whose knowledge has not been recognized as science by either colonial or national narratives of the history of science in the last few centuries have really struggled to earn that recognition from the state. And a common example that people here might be familiar with is acupuncture, which is used by a rising number of people in the US, but is not covered by most health insurance, let alone taught in medical schools. And the situation is quite different, for example, in Germany. So people seeking the recognition that their knowledge is science are often seeking increased access to financial resources, institutional privileges, as well as the prestige that science enjoys today in society. And scientists sometimes also offer some kind of recognition that other kinds of knowledge is something of a science, but there is still a hierarchy in their naming practices. So, for example, whose knowledge counts as botany versus ethnobotany? Who's a mathematician who does mathematics versus ethnomathematics? Medicine versus alternative medicine or traditional medicine. And part of the problem is that many of the ways of knowing the natural world that have existed before colonialism, before the past 500 years, have a really long history. But for many of us who are trying to learn them, our education, and thus what we can understand most easily, is shaped by the last 500 years of colonialism. So this makes sciences that are rooted in antiquity and the medieval period or even earlier much more difficult for us to understand. Because colonial history has made these ways of knowing seem less relevant to modern science, right? Like just think of the history of numerals that we learned in the last slide. I'm willing to bet that's not what any of you learned in school. It's definitely not what I learned in school, but it's very much relevant to modern science. These ways of knowing are just not considered history of science in syllabi or in curriculum. But historians, anthropologists, and practitioners of these ways of knowing are often hard at work to make sure that certain ways of knowing are legible to these broader audiences and to try and get them included. Like the example of traditional medicine, so traditional Chinese medicine, Tibetan medicine, Ayurveda, Unani medicine, any number of them, colonial histories also continue to shape the way that knowledges are regulated by nation states today. So whether they're acknowledged by the state as something legitimate, whether there are medical schools for them, people have licenses, etc. But understanding these histories can help create new categories for regulating these kinds of diverse practices, medical and otherwise. And maybe not all knowledge and experience should be assimilated into science. The UN, for example, increasingly uses the term traditional ecological knowledge, TEK. If all traditional knowledge has to be science to be valued, the knowledge of people who may have these various practices has to play down or completely lose the religious and cosmological components that might be a part of it. So, does this knowledge being considered science mean that indigenous people and nations are being compensated for their knowledge? Is it having any material effect on them? Or does it mean that environmentalists and other people learning from them are also supporting their own pushes for sovereignty and the return of land? Sometimes being considered science doesn't do all of that, or it hasn't yet. But inclusion in science may not always be desired or may not always be the best way of repairing the harm that science has done or that has been done in the name of science in the last centuries. For many communities, science really is primarily associated with histories of violence. And sadly, there are just way too many examples to represent this fully in this talk. One that is more well-known might be HeLa cells. Researchers have sometimes used human bodies, actually many times, used human bodies and remains without consent, leading to an enduring lack of trust in biomedical research today. So Henrietta Lacks was an African-American woman, and her cancer cells were taken to develop a very prominent line of immortal cells, the very first cell line of immortal cells that are used in labs all over the world. But her family were not aware of this. She was not aware of this, and let alone receiving any kind of profit or compensation. So one can understand the hesitation of people who know her story or who know the story of the Tuskegee syphilis trials, people who are part of the African American community or other marginalized communities to participate in clinical trials today or to receive treatment. Space programs, this may be a less known example, conservationists and biologists, as well as other scientists, have all participated in stealing land from indigenous and poor communities in the US, India, and a number of other nations. This isn't everyone, but various labs, various programs have done this. Scientists have instrumentalized settler colonial legal systems to often override indigenous sovereignty time and time again. So historically, for example, conservation has justified the creation of nature preserves. But indigenous ways of stewarding the land historically have not merited the same kind of legal or economic backing. Quite the opposite. Though some of these ways of knowing have recently been recognized, as I was mentioning, the UN recognizing traditional ecological knowledge, this hasn't stopped land theft, and this hasn't reinforced their calls for sovereignty. So people in the US and around the world have been wronged by scientists and in the name of science. How can researchers consider their families and community groups, as well as maybe journalists or artists or historians, to be their partners and collaborators in the future? Could this make science less extractive and more just? Could scientists reconsider whether some scientific and engineering problems are just not worth pursuing, when their solution seems to rely on appropriating land and resources through militarized violence? What if we recognize that scientists' priorities do not always match those of local communities, but scientists shouldn't necessarily get to bulldoze forward anyways? Local communities should be respected. Indigenous peoples' historical ways of knowing and stewarding the land should be respected. People's consent over their bodies should be respected. And this is beginning to happen. But learning about the past and present harms needs to become a standard part of scientific ethics. On a related point, scientists' insistence on universality as a condition of science has destroyed many efficacious ways of knowing the world and local knowledges. So making science as it exists currently more diverse doesn't exactly solve these kinds of problems. Even finding the hidden figures or the invisible technician in the past isn't necessarily enough. The extractive nature of the sciences today must be addressed head-on. For example, biopiracy. Local medicinal knowledge of plants can only be considered science if it can be transformed into a product sold on a global market. Indigenous knowledge cannot continue to be just viewed as an extractable resource with no regard to the way that it might harm or benefit those knowers or their claims to their land or livelihood.
So for the last part of this talk, we're going to consider a few examples of the kinds of cooperations that are working towards these more just presents and futures. And we'll start with a botanical example of respectful cooperation and collaboration in the work of Dr. Ina van der Broek, who's an ethnobotanist based at the New York Botanical Garden. Her research focuses on the use of unprocessed medicinal plants that are found in New York City's botanica shops, which are popular among Caribbean and Latino communities of New York City who use herbal remedies as well as biomedical care from the public health system to address their healthcare needs. So understanding the dynamic interaction between these two healthcare systems is especially important because 30% of New York City's population is of Latino descent, and Caribbean communities are the largest group of foreign-born individuals in the city. And what Dr. van der Broek is doing in her work is trying to understand all of the kind of the spectrum of herbal remedies that are available in New York City's botanica shops and how they might interact with the kinds of drugs that are being prescribed by physicians and other biomedical practitioners within the healthcare system. People using herbal remedies don't always want to disclose, for the reasons of mistrust that Shireen identified, to physicians or other healthcare workers that they're using multiple different forms of healing. But the interactions of those forms of healings could have very negative consequences. And so helping healthcare providers understand why some of these communities might be using other multiple forms of healing, what the effects of some of those interacting multiple forms of healing might be, is a way of training healthcare providers and physicians to be better informed about the complex nature of the medicinal and healthcare needs of their patients, as well as respecting their patients' autonomy to seek healthcare in multiple forms and preventing further harms from emphasizing pharmaceutical, sort of official pharmaceutical drugs over plant-based remedies. So studying knowledge communities on their own terms can lead to more equitable care, more culturally competent education for healthcare providers, and ultimately for better health outcomes, especially amongst populations who historically have not been the beneficiaries of public healthcare systems. A second example is in the realm of environmental stewardship, as Shireen highlighted before. There is a kind of growing trend to recognize Indigenous stewardship over land, respecting historical terms of treaties and agreements, as well as recognizing the history of the violations of those treaties and agreements. And this has been finally achieved in a century-long struggle in the return of the national bison range, as well as its resident bison herd in western Montana to the Confederated Salish and Kootenai tribes. It started as the last, one of the last free-roaming bison herds on the Flathead Reservation that was managed by the tribe in the 1870s. And the federal government decided that the best way to protect the herd from the ravages of what had been a mass project of extermination was to seize land that had been given to the tribes as a reservation to create this conservation space within the physical reservation. So there was a federal national park within the enclosure of the Flathead Reservation that was managed by the federal government for the purposes of protecting the bison that the tribes had themselves protected, having been confined into this space. And so it's taken the past century to recognize the injustice of not only the conditions that led to the creation of the National Bison Range, but the hypocrisy of maintaining it within the space of sovereign Indigenous land. And so that land is finally in the process of being returned, as well as the bison, to the community that has historically been the custodians of the land and has the environmental expertise to manage it. So these are just a few examples of work in progress and approaches to humanizing science that are still emerging in our moment, which is exciting. And we want to close with a few other examples of what historians of science are doing and can do to help in these efforts. So the first is teaching history of science. As I hope we've shown, there's a huge educational component to what it is that people understand science to be, and how where they think it comes from affects what they think it can do and who it can do things for. Largely, history of science departments still reflect a kind of scientific revolution, Western European centered narrative in the history of science. We hope that the work that lots of scholars are doing can be incorporated into a new narrative that doesn't necessarily center one place, but is about the interactions, about these multiple stories. That does mean also thinking about what the nature of the field and being a graduate student or a professor is one of a relationship of collaboration and being willing to go places you don't know things as much about, not being an expert in everything. And as long as we rely on a single narrative, it will continue to be co-opted by people whose interests it serves, and especially in issues of white supremacy and colonial narratives that remain unchallenged by the sort of single story. So in addition to teaching history of science and making history of science accessible in various curriculums, partnering with the communities that those histories have affected is especially important. A really wonderful example of a scholar activist, Chonda Prescott Weinstein, whose recent book we also linked to on our handout, has worked with other astronomers in her field, as well as Kanaka Maoli activists and historians, to challenge the development of a new telescope on Mauna Kea. Science communication is also a really important area where historians of science can intervene. And historian of science at Harvard, Naomi Oreskes, has been really influential in showing that the history of the scientific consensus around climate change, as well as the historical process through which that consensus has been distorted and distrust in science has been created, for example, through the production of uncertainty about the credibility of scientific results. Historians of science, medicine, and technology are involved in litigation, seeking reparations, accountability, and justice, especially in the realm of public health. Historians, including David Rosner at Columbia, Alan Brandt at Harvard, have been critical to documenting and litigating historical injustices perpetrated by chemical industries, especially, and revealing the ways that scientific data and information have been suppressed, and that these industries have continued to ignore the claims of harm and damage, especially to children, workers, and urban communities, overwhelmingly impoverished ones. In the new Biden administration, for the first time, there is a historian of science and medicine and science studies scholar in the Office of Science and Technology Policy. Dr. Alondra Nelson has the title of Deputy Director for Science and Society, which is a hugely exciting new role for someone who studies the relationships between science and public communities, and the way that those questions of race, of health, of genetics are driven as much by community needs as by scientists will be really critical in having that in a policy, that expertise in a policy role. And similarly, historian of gender and biology, Londa Schiebinger, who's based at Stanford, has been a really powerful advocate in bringing gender as a form of analysis to biomedical research, both in innovation and discovery, showing that considering gender actually not only is important because it's historically been ignored in biology's history, but it actually tells you a lot about biology. And lastly, in training new generations of researchers, history of medicine is becoming more and more central to the curriculum of in medical schools. And Shireen and I are firm believers that every discipline should be considering its own history as part of the training. If you're becoming expert in something, you should understand its history. Teaching medical, in the case of training physicians, this means medical ethics, cultural competency in providing care. I think we've given a lot of examples of how it could really make a difference. And lastly, this talk, I think, is an example of the kind of work that we want to see happen, going beyond our realms of expertise, learning a lot in order to really substantiate the points we want to make, and also working collaboratively across institutions, across different subfields within the history of science, even just putting ourselves out there to give this talk feels like an important step. And in our own research as well, it's something that we're trying to implement. So I've recently been partnering with a geologist who reached out to me because she wanted to better understand the history of her own field. And I've helped her develop a list of online resources on the history of colonialism and geology, and spoken to her class that she developed for her own students because she felt the strong need to educate geology majors about the colonial history of their field in order so that when they go out into professional or research roles in the earth sciences, that they understand these dynamics of how central extraction and colonial appropriation has been to the geosciences. So she's helping them to better understand this history by working with historians of science, but also implementing it in the way that the geological collections are organized at her institution's museum and in the curriculum, so that her students can better redress the impact of these past harms.
I'm really excited to see that syllabus. Yeah, I think Claire and I have done a lot of talking in this presentation about how scientists are complicit and need to be, alert to the historical inequalities in their own disciplines. But both Claire and I are in a colonial discipline as well. History as well has its own history of being implicated in creating inequality and has implications for more implications for certain communities than others. And so as I work on the history of a medical tradition, though I'm focused on the medieval period, this medicine is absolutely still practiced in a number of places, including India, where it's called Unani tibb. And I could actually get my degree quite easily. No one would challenge me if I just sat here, at Harvard doing my doing my PhD on these old medical manuscripts and publish what I publish. But I'm hoping not to reproduce injustices that historians have made in the past, and I'm building relationships with practitioners of this medicine in India, Pakistan, and hoping that these conversations, finding out, what do my ideas mean for you, how maybe their views on my ideas may in turn shape the way that I understand my sources. This is an integral process of research for me. So I hope also to be able to eventually produce a dissertation in some language or medium, probably Urdu, medium yet unknown, that would actually be conducive to the needs of these practitioners, that might be of interest to them and something they can use and share as well, a sort of usable past. And so these are, as Claire said, absolutely works in progress. And we are really grateful to be here in conversation with all of you today. Some recaps from this last section. The harmful histories of science and the harm that science has done historically cannot be ignored anymore. Science has often served capitalist and colonial interests and been used to exploit people for its own interests as well. And this history really impacts which knowledge is considered science today, which isn't, as well as the trust that people have towards science. The reparative efforts that we can make now need to move beyond inclusion and diversity, just getting more people of color or LGBTQ folks or people with disabilities in the room. That's all important to do, but that's not enough. We need to transform what we think of as scientific ethics itself. And finally, fair and genuine partnerships between scientists, historians, and community members is a really good direction to go in to pursue that goal. So with that, we will open it up for questions.
Thank you so much. That was amazing. We already have a few questions, but again, I will repeat myself. Please put your questions in the chat, either in Zoom or YouTube, and we will slowly get to them. So to begin with, we have a pretty straightforward question. What is ethnomathematics?
That's a great question. So the first time I came across it was a TED Talk by a scholar whose name is escaping me right now. He himself is a mathematician, and he was studying logarithmic ways of doing math in divinatory practices. So practices through which people can know something about the future in West Africa. So this is called geomancy, kind of using sand and patterns and as well as logarithmic ways of interpreting them and understanding them to kind of understand what's going to happen. That's simplifying it a little bit, but it was really mind-blowing for me because for some of us who teach history of science, like for example, history of medicine, if I'm have a class about this, I can't really ask my students to try to recreate like a past recipe for a number of reasons. But maybe one day someone will let me do that. But for mathematics, like, mathematicians can actually, and they absolutely do sometimes, include different ways of doing math in their classrooms. Like base 60 mathematics is regularly taught now as like, okay, a totally different way of like using numbers, but one that's been extremely popular and used in astronomy and a number of other mathematics historically for like the past 200 years or more. So, 2,000 years or more, definitely longer in Mesopotamia. So yeah, I think like ethnomathematics is basically what mathematicians use to distinguish all of those ways of doing math and using numbers from what's done by contemporary mathematicians today, if that makes sense.
That's very cool. Claire, you unmuted. Are you going to add something?
Oh, no, sorry, I wasn't trying to comment on that. That should be the final word on mathematics.
All right. The next question relates to what you were talking about, the local communities that labs should be mindful of, or science groups. So what did you mean by local communities? Communities labs are geographically situated in, communities the lab members and technicians are from, communities the research is based in. With the international and interconnected nature of science labs today, how do we think about community?
That's such a good question. I think the answer is all of them. I mean, I think that's the goal, is understanding it as interconnected. If you are ordering, your biological material from another country, like, make sure you know where that material is coming from. If you have a diverse group of people working in your lab, you should know who you're working with and what the work means to them. I mean, I think that's a pretty reasonable expectation. And yeah, investing in those relationships, I think is absolutely necessary. But the question of what a local community is a really important question, because it is a term that can mean a lot of different things. And so I think that also has to come from, the work that you're doing and the people you're doing it with, asking them what the work means to them and how they got involved, how the relationship is working for them, all those kinds of things. I mean, rather than just trying to articulate a lot of boxes just so that you can check them.
That's very helpful. Great. All right, moving on to another one. Would another tool of humanizing science be to break down current barriers, such as traditional PhD experience and publication records, to becoming scientific figures and/or leaders in academia?
That's a cool question. I feel like the speculative kind of mode of thinking is something that I really enjoy, and that it's like one of the cool things I think history of science also can kind of show us, is like how contingent the current organization of things really is. Like, okay, when was this decision made that things are going to look this way? So yeah, I think the professionalization of the disciplines is definitely something, if you're interested in, you'll find a lot of material on in the past, like how did it come to be, in these different disciplines? When was the decision made that to have a position, you absolutely need a PhD and a postdoc and all these publications? I think that having multiple routes, or having routes to kind of participation in research, having positions in labs that are guaranteed for people who have less qualifications would be an amazing step. Because a lot of the work that's being done, you don't need a PhD for, and a lot of the work that's being done, maybe, I hope I can say this without offending people as someone pursuing a PhD, but sometimes a PhD can really hinder you from seeing things, from understanding things in a particular way. You're being disciplined into one particular way of interpreting and understanding material information. And that's very useful, but it's limited. It's like by design, it's limited. So it's like a very precise and very, very strong tool. But sometimes you need people with different tools. So I think that labs should be hiring artists. I think that there should be an artist and a historian in residence at every big lab group. And I think that kind of exchange and the way those dialogues would happen about the material would be so stimulating for everybody involved. But I know that's not exactly your question, but that's kind of one of my pipe dreams.
I identify with that dream. So there's one more question, but you should feel free to write them down in the chat. Otherwise, we're going to ask that and head out. But I am putting our feedback form in the chat. So if you are slowly leaving us, please fill out our very, very short feedback form. All right. The last question that we do have right now is, Historically, what has been the relationship between science and the industry and science and academia?
What a big question, but it's a really, really important one. So, I mean, science and industry is something that I guess I feel like I've tried to think a lot about in my work. I mean, my research happens in the 17th century, when what an industry is looks really different. It's all manual to some degree, and my answer is they're really inextricably related. I mean, science is as we referred to it a lot of times, as a way of solving social problems, and you know, those problems are a lot of social problems are material. How do you get more food? How do you get food how do you grow plants that are drought resistant? How do you heal sick people? How do you get more drugs? And a lot of those questions are really related to the marketplace, as well as the work that people need to do in order to get those materials. So whether that's, you know, drugs, which since time immemorial, drugs have often been something that is considered to, you know, be more efficacious the more expensive it is, and the farther away it comes from. That is a very, very old stereotype. And so access to drugs depends on, you know, the drug trade, which, along with spices, along with often enslaved peoples, along with cloth, along with precious metals. I mean, these are some of the oldest forms of trade that we have archaeological evidence of. So they're really inextricably related, but of course, what industry means something really different in the 19th and 20th century than it does, you know, in older pasts. And so as industries change, science has changed, and often what you can see in the 19th and 20th century is that science kind of industrializes. So the question about universities is really interesting, because they do, as Shireen, I think at one point mentioned, a gentleman scientist. At one point, the figure of a scientist was supposed to be someone who was at leisure, who had the leisure to kind of, you know, investigate things for its own sake. And science comes to be sort of mass manufactured, right, through the kind of protocol of universities. So yes, I would love to see more leisurely scientists, more leisurely university experiences, a much wider variety of educational institutions. I think we could think about ways that our education systems have also kind of become industrialized in ways that don't often serve social equality or probably science. I think a lot of people working in labs feel like they could use a less industrial form of training. I know I certainly feel that way in my own PhD at times. So yeah, it's a really big question, but it's a really, really important one. And it speaks to the issues of funding, it speaks to issues of educational training, and also a place to advocate for change, I think.